We're back recording. Thanks to Daniel Pagani. And now you are famous. Your name is down forever. Circles. We know the circumference of circles, 2 times pi times the radius. And we want to develop an understanding of how we can figure out the area formula. Brittany's about to be famous too. If we take a circle and we cut it into little pieces like you were slicing up a pie right over here, would it be true that if I added up the areas of each of those pieces, it would equal the area of the circle? Yes, nothing fancy going on there. If we took every other piece and laid it out with the base on the bottom, and then all the pieces in between and laid it out on top, it would make what shape almost exactly? Parallelogram. A parallelogram. Now these pieces down here on the edge, are they straight? No. Now if I cut that circle into smaller and smaller pieces, would those end pieces get more and more straight? Yes. So the idea in math is actually called we take a limit. We keep doing it until those little pieces at the end get smaller and smaller and smaller. We say we limit them to 0. But as I get smaller and smaller pieces, which means more and more individual pieces, but those ends get more and more straight. So it becomes closer and closer to a straight line right down here. Well, let's go ahead and just say I have cut it into 1,000,000 pieces. Or 2 billion pieces, or it doesn't matter, because we know that the distance all the way around, 2 pi r, so half of the pieces down here on the bottom would be half the circumference, or 1/2 of 2 pi r. Well, that's just pi r. 1/2 of 2, those cancel out, and I just have pi r for the base of this parallelogram. What's the area formula for a parallelogram? Base times height. So if I took the base, pi r, times the height, now what is the height of this parallelogram? The radius. The height of the parallelogram is the radius of the circle. So I'm going to multiply it by the radius. What's pi times r equal? Pi r squared. You ever heard of pi r squared before? The area of a circle is pi r squared. Now, I just talked about doing all those kind of cool, nifty things, but let's watch what happens if we try to do those cool, nifty things. Let's see if I have this opened up enough. Hopefully it will fit in the recorded area. We will see if it will work. Shrink it down. All right, have to be inside my red recording rectangle over there. Straighten the circumference. Watch what happens when I slide this around. See that circumference? There it goes. We're just unrolling it, and we're laying it out right down there. So we have done the circumference. Check. Now we're going to dissect it. You know, like in biology, we're going to cut it up into little pieces. So we're going to dissect it. Ooh, look at that. We just chopped it into a whole bunch of pieces. Now I can chop it into more pieces if we want to. So let's do 48 parts right down there. Okay? It kind of, yeah, it does. Kind of look like a sunburst right there, doesn't it? Now let's start rearranging these pieces. So here we go. We're unrolling them. Well, of course. In cartoon, little intervals, you know, little motion, so when you flip your book, you can see it in motion. So here we are. We're laying it all out. Laying it all out. Now we're going to take this second half, and we want to flip it back over on top of that first half. So there it is. And what shape does this one? We've chopped it into so many, it looks more like a rectangle almost. What does it tend to? Kind of looks like a rectangle up there. What are the dimensions of that shape? Do you remember the length across the bottom? Pi r is the base, half the circumference. 2 pi r is the full circumference, where half of 2, 1 pi r. And the height is the, what's the height? R, the radius down there. So the area of the circle, we did it a minute ago. It doesn't show it here. Shame on them. But pi r, base, times height r, pi r squared.
What happens when you increase the number of...
It gets more and more like a rectangle. Ours was pretty parallelogram shape up here. But the more pieces, it gets more and more like a perfect rectangle. And the ends, the bottoms and the tops are flatter, straighter and straighter. So maybe that gives you an understanding of, okay, I can kind of see why we have this area formula. Area is pi r squared. You have a piece of notepaper maybe? You've been writing area formulas? Maybe you know this one. I don't know. But that's another area formula we need to make sure we know. Easy today, because circles is something you have learned a long time ago, I bet. What is the area of the circular putting green shown to the nearest foot? Well, starting with our formula, area equals, what's the formula? Pi r squared. And so our radius of this cool circular putting green is 10 feet. So what's 10 squared? 100. If I wanted the exact area, we would call it 100 pi feet square. Now they said round it to the nearest foot. So approximately, you've got a pi button on your calculator. 31. How in the world did Eddie get 31? Pi is approximately 3.14. 31? Where did he get a 31 from? How about 314?
Yeah, we didn't know how we got it.
314, if only it was 10 that we were multiplying by. That's right. What's a decimal place among friends? Example number 2. Find the radius of a circle that happens to have an area of 95 square centimeters. I'm going to start with my formula. I'm going to fill in the values I know. I know the area, 95. And we are trying to find the radius, it says, of this circle. Divide by pi. That would take care of this pi right here. And then what? Square root. We need to take the square root of this 95 divided by pi. That will give us our radius. Approximately, now let's make sure you can do this right. 5.5, anybody else? Seems awfully small for a radius. Maybe not. Yeah, maybe not. 5.5 squared, let's double check it. Seems like it's a little bit small, but you're probably right. 5.5 squared times pi. You getting about 95? Yeah. All right, we'll believe it. The area of a circle is 196 pi square yards. Find its diameter. Well, area is pi times radius squared. We only have one area formula. Area is 196 pi, so I'm just filling it in. Pi times the radius squared. There you go. I can divide both sides by pi. So if 196 equals the radius squared, how will I get the radius? Square root of 196, which is approximately, why don't you give me a couple decimal places? It's exactly 14, isn't it? And I want the diameter, so what do? Multiply it by 2, and we discover 28 yards is going to be our diameter. Nice and easy. So let's take a piece of a pie. Some of you, when you see some wonderful warm apple pie, you say, I'll take that piece right there, about a quarter of the pie. Do you remember we had a formula for the length of an arc, not the measure in degrees, but how long an arc was. And an arc is just a fraction of the complete circle. So we took whatever fraction it was. Maybe it was a 10-degree arc. Well, that's 10 degrees out of how many degrees? 360. That fraction times the whole circumference. 2 pi r. Same idea works here. If I want the area of a sector, it is called, when you have a piece of a circle, this is a sector right in here. Well, that is some fraction of the complete circle area. So I just need to figure out what fraction it is. So I have, right here's my formula, x, what fraction out of 360? How many degrees out of 360? Times pi r squared. That fraction times the area is all that we have to do. A circular pizza has a diameter of 12 inches, and it's cut into 8 congruent slices because I didn't cut it, so they're all congruent. What's the area of one slice? And they want it to the nearest 100th. Well, my area is going to be some fraction, excuse me, something out of 360 times pi r squared. How many degrees out of 360 do we have if we are taking one of these pieces? How many?
45.
Is it 45? You could do 180 divided by 4. You could do 360 divided by 8. You could do 90 divided by 2. 45. 45 out of 360 is what fraction?
1/8.
1/8, which is an easier way of doing this one. I use the formula, which is good. We have 1/8 of the full thing. Times pi times, what's our radius on this one? 6 squared. Diameter is 12. So what's 6 squared? 36. I have 36 out of 8 pi. What I want to do is simplify this to its exact value. Then we'll go to our decimal, because often we want the exact value. 36 over 8, how does that reduce?
6 times
4.5.
How does it reduce as a fraction?
over 2.
Okay, 9 pi over 2 would be the exact answer to this problem. In case, which is going to happen to you, you are asked to do exact values. We just reduce our fractions. 9 pi over 2 square inches. Approximately, now to your calculator and tell me to the nearest hundredth. 14.14? 14.14 inches squared. Which part is your questioning? The last one down here? I took 6 squared, 36 times 1/8, so there's 36 over 8. So 4 goes into 36 9 times, 4 goes into 8 twice. Exactly right. That's how we got 9 pi. Remember, something by itself is in the numerator. It's in the top of the fraction. 9 pi over 2. Find the area of each stated sector. They want us to round to the nearest tenth. So starting out with my formula, area is going to be, I'm going to have to write some sort of fraction. Tell me the fraction. 53 over 360 times what?
4 squared
Pi times 4 squared. They want you to go to the nearest 10. Try your calculators. So we won't reduce this one. We'll go to the nearest tenth. Nearest tenth, they said, yeah.
Oh, I thought you wanted the fraction.
7.4? 7.4. 7.4 feet square. There's the area of that sector. So trying this one, area equals 148 out of 360 times
6 squared pi.
times 6 squared, which is going to give us to the nearest tenth
46.5.
46.5?
46.
All right. We'd like to get agreement. All of you should be trying this. This is the time when you figure out if you are entering and using your calculator correctly. You don't want to do all your homework wrong. Area of this sector equals,
No, 295.
295, where in the world does 295 come from? Where's our 295? 360 minus 65. We want the shaded part, all of this part in here, times pi times 11 squared. 311.5? What are we, inches? Inches square over here. That would be a very large circle if it was 11-meter radius, yes. The color wheel at the right is a tool that artists use to organize color schemes. If the diameter of the wheel is 10 inches, and each of the 12 sections is congruent, find the approximate area covered by green hues. And in case you don't know, they kind of put a nice little black line around the color green. Some of you maybe are red-green colorblind. I don't know. It's pretty common.
It's green and orange.
Is it green and orange? Do they look the same color to you, the green and orange?
Yeah, I always think.
Very cool. How am I going to do this? Ah, how do you get that it's a right angle, James? Yeah, I've got 1, 2, 3 out of how many? I've got 3 out of 12, or 1/4. Need everybody's attention. Thank you. Pi, help me out. Agreed. 5 squared. Our radius would be 5 because they told me the diameter was 10. And they want the approximate area. Unfortunately, they don't want the exact value.
I like this part.
5 squared is 25 times a fourth. Here's the exact value. Whoops. It's very easy to do. In fact, it's easier than having to get the approximate one. 25 pi over 4. That's the approximate one. I mean, that's the exact one. Nearest tenth. Approximate area. 19.6? 19.6. And our unit, we're in inches. Inches square. Let's go to your books.
I like that.
Isn't this a nice lesson? No? Maybe they'll find some way to make you work a little bit. We'll see. We are on page 800. Number 1. Find the area of each circle. Round to the nearest tenth. So area equals pi r squared, so it's going to be pi times what? 21 squared. Nearest tenth.
I'm scared. 1,385.4.
1,385.4 yards square. Number 2. We're still finding an area, aren't we? Area equals pi times what? 0.2 squared. They gave us a diameter, so we want to make sure we find the radius before we square it. Nearest tenth. 0.1. Kilometers squared. Nearest tenth. Number 3. Find the indicated measure. Round to the nearest tenth. Find the diameter of a circle that happens to have an area of 74 square millimeters. Area equals, let's write the formula, pi r squared. I know the area, 74, and I don't know anything else. What do I do next? Divide by pi, and then take the square root of that. The radius will be the square root of 74 over pi. Why don't you go to 2 places on this? It's not our final answer. 4.85. And then what do I need to do with that number? Multiply it by 2 because they wanted to know what is the diameter. What is the diameter? 9.7? What was our unit? Kilometers, millimeters? Millimeters. Is it square?
Yeah.
No, it's a length. So it's just millimeters. Number 4, area of a circle is 88 square inches. Find the radius. So we know area equals pi r squared. 88 must equal pi r squared. So we can divide by pi. And then we can find the square root of 88 divided by pi. And they wanted the radius, I believe, didn't they? 5.3 inches. Again, that's not squared because this is a length unit, not an area on that problem. What is today? Monday. It is the 31st. Find the area of each shaded sector. Round to the nearest tenth. Area equals, tell me some numbers for number 5. 57 over 360 times pi times 3 squared. And they want us to go to the nearest tenth. You should be getting 4.5. Again, run it through your calculator. You want to make sure you are entering these correctly. And now's the time to find out. Number 6, area equals 92 over 360 times pi times how much? 7 squared. What was the number again? 39.3 centimeters square. Chelsea's baking pies for a fundraiser at her school. She divides each 9-inch pie into 6 equal slices. When they refer to a 9-inch pie, what are they talking about? What is 9 inches? Diameter. That's what they're referring to. So part A, what is the area in square inches for each slice of pie? So part A, how will I get the area of one slice? How many pieces is she putting it into? 6 equal slices, so we could go right to 1/6, right? We have 1/6 of the total area. 1/6 pi times
4.9.
Where do we get 4.5 to square? Diameter of 9. Half of 9 is 4.5. Nearest tenth. .6 inches square. Part B. If each slice costs 25 cents, she needs to raise her prices. Oh, 25 cents to make. And she sells 8 pieces at $1.25 for each slice. How much money will she raise? Tell me the math we'll do to get her answer.
0.25 times 4. Wait, times 6.
Why don't we do that? 8 pieces she sells at $1.25 a piece. Oh, does it say 8 pies? Oh. Well, so let's go ahead and start 8 times $1.25. That would be, oh yeah, 6 pieces. 6 times $1.25. That would be how much she sells one pie for, is that right? What's 6 times $1.25? $7.50. And then we need to multiply that by 8. That's the total. $60. Now that's not the money she makes. That's how much she sells it for. So what do we need to do?
6 times 25 cents.
Okay. 6 pieces, 25 cents to make each piece. Is that what it was? So that's how much for one pie?
Pretty cheap pie. Yeah.
6 times 0.25.
That's
$1.50. And then we'll have to multiply that by 8. So that's a total of how much cost for the 8 pies? $12. And we'll subtract our $12 from the $60. She's going to make $48. That's right. You go, girl. Page 800, numbers 1 through 37.